Okay, today is 9.5 math induction. All right. Induction is a way of proving, or we are using induction to prove statements to be true. All right, so let me give you an example of a statement that a kid could make to you and how you might prove it to you. Let's say the kid said, you know, if you take something and you square it, all you have to do is take that thing and you times it by 2. Okay, and here's the proof that they would give you. That this is their statement that it works, and here's how they could prove it. See, all you got to do, stick in 2. If you stick in 2, 2 squared is equal to 2 times 2, which is 4. So, see, all you got to do is take it and times it by 2. That's a flawed proof, isn't it? I stuck in a number that happens to be the only number in the world that would ever work for that. Get what I'm saying? So, can you prove this statement by showing that for one case it works? No. That's the point. Just because it works when you try it with one set of numbers, it might work that time, but it might never work again. Okay, so to prove something by induction, you have to do 3 steps. You do actually have to prove that it works for a simple case with a number. And we always just keep the simplest case of all, which is to stick in 1. Okay? And so I want you to just understand this blue statement first of all. It's saying a sequence of terms, and you guys have gotten good at sequences by now. You know that they're like, oh, a sequence. I'd like you to write me the little series dealy bob for that. Just the red part, the part I circled in red, you can write me that in series notation. That would be a typical question that you might have to write. On your test. It'd be totally different if I said I want the first 4 terms. I didn't. I want the first n terms. It starts at n equals 1 to not 4. That would be if I wanted 4 terms. What should I put up on the top? N. I don't know how many terms it's going to go to, so I'm going to put an n. I didn't say it was infinite. I didn't say it kept going forever. That's different. All right. And then the little series would say what? What in there? 5. No, that would be if you're listing them out. The rule for it. 5 what? 5n. Now, if this is true, if my little generator makes the right terms, then when I stick in the first number, if I stick in n is 1, if I stick in a 1, do you see I get a 5? If I stick in a 2, do you see I get a 10? If I stick in a 3, I get a 15. And how many times do I want to do it? I didn't say, so I put an n on top. What if I wanted to do it for infinity? Yeah, you can make this infinity. But then this rule wouldn't work. This rule only works for n number of times. So let's try, I want to just show you a, oh, I just hit the wrong button. Hold on just a second while I find where I was. There it is. Okay. I want to show you the case of the first 4 terms. Would you agree if the first 3 terms are 5, 10, and 15, that the next term would be 20? You with me so far? Okay. Now let's prove that this little rule thing actually works. That thing right there should also tell us the answer. All we have to stick in is how many terms we had. How many terms do we have? 4. So what should I stick in? 4. So then everybody right now, on your paper, prove whether this little rule is true or not for n equals 4. Wait a minute, and it's 4. I'll pause for a second while you just verify if that actually works. Did it come up the same? So the left side here It's just adding. So what does that add up to? 50 is equal to the right side. Does that actually come up to 50? Let's see. It should. 5 times 4 is 20 divided by 2 is 10. 10 times 4 plus 1. Now that looks like it would be 50 to me. Do you get that this system is working? That thing on the right that I circled in black, that is a rule that would work to add up any number of terms in that sequence. Okay. Now to prove it though, just because it worked for 4 terms doesn't mean it works forever, for anything. So to prove something by induction, pause for a second. Okay, so to prove this by induction, there is a 3-step process. You need to take copious notes at this point because your test involves explaining these 3 steps to prove by induction. Okay, step 1 is to make sure it works for n equals 1. That would be the simplest case, right? If we wanted to do 1 term. So everybody write down this, stick a 1 in it to verify that it actually works. We just proved it for 4 a second ago. Now we're just proving it for 1. Why don't we have this other stuff? Because we only have 1 term. The 1 term is that 5 times the 1. Okay, so 5 times 1 equals 5 over 2 times 1 times 1 plus 1. And hopefully when you multiply that all out, it will actually be true statement. On the left side, 5 times 1 is 5. 5 over 2 times 2. 5 over 2 times 2. That's over 1 then, right? So then the 2's cancel and it's 5 equals 5. Yay! Now, of course, that would be wonderful if that was all you had to do. But that's the simple part. You're just sticking in 1, proving it works for 1 case. Now, does that prove it works for all cases? No. So now I have to extend this and say, does this seem reasonable to you if I said I can prove this for any number that anybody ever picks, that would be a way of proving that this rule works? I mean, that's kind of what it means, is no matter what you pick, it will work, right? So this next step is confusing, like why we would need to do it. But step 2 is to set n equal to any number that anybody would ever pick. And the standard for math induction proofs is you say k. Now I know n and k are both variables, but this is a standard thing, kind of like a u substitution in calculus. We always use u, kind of like we always use pi to mean 3.14. It's just a variable. Pi is a variable, but we don't use it like a variable. We always use that. Okay, well, in math induction proofs, we always use k. Okay, so let n equal k. Now, all I have to do then is copy down the original, including the whole thing, except wherever you see n, you put a k. This is just a copying task. This should be very easy for you. Go ahead and do that right now on your paper. Copy the original formula down exactly, except wherever you see n, put a k. Nothing to do. You're just rewriting the original formula. Do you get that I just copied the formula over again? I didn't do anything here. I just stuck a k in. That's it. I swapped out n and k. And I get that that's confusing on why you'd need to do that, but the standard for math induction, we use k. K could be anything, like let's say I had Sem pick for me. Pick anything, any number he wanted in the world. Then we're just letting that be K. You pick some number. Now, do you get then, we don't know what that number was, but we know what one bigger than that would be. K plus 1. So step 3 then is you make sure it works for not K, but K plus 1. That would be the next term after it. So the ladder was at the very beginning of this assignment because, how do you get to the top of the ladder? It's like, how do you get to the end of the proof? The first step, the first rung of the ladder is proving that it works for any simple number, like 2 or 1 or 17. We always start with 1. Okay, so you prove it works for the simplest case. Then you prove, to get to the next step, the next layer of proof is if I could prove it would work for any other letter, any other variable, any other number of terms I want, then if I could prove it would work for the next term after that, it's going to work for everything. Okay, so now I have to make sure it works for K plus 1. How do I do that? I'm going to copy this original again. And I'll just rewrite it. But okay, so my original again, except I got to leave a little space. I know you don't want to copy it again, but you need to. 5 plus 10 plus 15 plus ... plus 5K. Now you got to leave some space. Leave some room. And then 5 over 2 times K plus 1. And I have some room after it. Again, I have done nothing. All I've done is copy the problem, except I left some space. Why do you think I left some space on both sides? Because what's the next term after 5K? If K was any number that he picked, the next number after that would be what? K plus 1. And therefore, what should I put right here as my next term? 5K plus 1. Are you copying this? You need to. I know you're going to feel like you're understanding it. You'll remember 10%. It's not enough to even pass. All right. If you add 5 times K plus 1 to the left side of the equation, just think about it. Don't you have to add it to the right side of the equation? That's just logical. By algebra, if I add 5 times K plus 1 here, I've got to add it right there. Are you following me so far? Because this is the level that you are required to get on the question we are going to give you. If you can just get that far, you've proved that you understand the proof process, but not that you can actually grind out the algebra at the end, which I'm about to do. Okay, so this is the level that's very easy. It really isn't that hard. You have to remember 3 steps, but it's very easy to do so far. I mean, it's easy for me to say because I know how to do it, but I don't think it's too tough. But if you can get farther than that to actually prove it, all we've done is set it up. We haven't actually proven anything. If you can prove it, then you'll get more credit. Can't explain to you exactly right now how that works on the test, but I can tell you that on the test on Friday, if you can go further than this, you will get a higher grade than if you just have to stop there. This is the minimum level that we would expect you to know. kind of like an R2. If you can do the whole thing, which I'm about to show you, then that would be like A+ level work on this problem. Okay, so let's see if you can hang with the rest of this. I'm going to just do a quick, like, what did we do again? Step 1, we just had to make sure it worked for 1, simplest case. Step 2, we set n equal to k, because that could be any number anybody would pick. And all I did is swap it into the formula, and it's the same exact formula as it was before. Then the next term after it, if we can make sure it works for that, then we'd know it was really true. And if I could solve this somehow, not really solving it, and proving that it comes out right, then I would have proven that this whole statement that was originally given to us is going to be a true statement for any n. Yes? That is a very good question, and that is the next step. Okay, now would you agree, I can't, if I add 5k plus 1 here, that I have to do the identical thing to the other side? I can't just do this here and then do something completely different there. You get what I mean? That would be different. This is an equation. I added this piece. If I add this piece to this side, I have to add that piece to the other side. That's just the rules of algebra. I can add anything I want. If I want to add 57 here, I can, as long as I add 57 there. Do you get that that concept applies? So this one was easy to see what it should be, because this was 5k, and we just chose to add a 5k plus 1 there, because it was the next logical term. All right, so now, but what you said is important. What you said was, why didn't we just stick in that other formula, in this formula right here, here's the original one, why didn't we just stick in a k plus 1 wherever there was a k? And that's exactly what we're trying to prove, that this will equal. Okay, so I'm going to do a bunch of algebraic manipulation to this and prove that it ends up equaling the same thing as if I had just stuck in a k plus 1 here and a k plus 1 there. That's the goal. Again, I know I'm getting into high-level stuff, and we're already in a high-level class. So this is kind of complicated. So I'm going to take what I have here, which, again, I don't think we have actually done here so far is that hard. We have added 5k plus 1 to both sides. That's not tough, is it? Okay, good. So that's as far as you have to understand math induction for this next test. But some of you, in fact, I'd say a good half of you are going to be able to handle the algebra that I do next that will prove that this is really true. All you have to know, because we have a short time. I mean, it's Tuesday, you're being tested Friday. You can't be masters of math induction by then, but at least you can know how to set it up. Okay, so some of you, though, will be masters of math induction by Friday. So I'm going to take this part right here, and I am going to rewrite it, except with more room. 5 halves times k, and I'm going to be careful with where I put that, because that k is really technically over 1, isn't it? Isn't k the same as k over 1? Okay, so isn't this the exact same thing as 5k over 2? Get that would be 5k over 2? Okay, good. All right, and I'm going to multiply that then by k plus 1, and then I have plus 5k plus 1 on the end here. And what I want to prove that it will equal is, hold on just a second here, I want to prove that this will equal the same thing as if I had taken this formula right here and just replaced k with k plus 1, because that's what we want to happen. I know some of you are saying, why didn't you just do it right here? Why didn't you just do it? Because math, the rules of math don't allow me to do one thing on this side and something different on the other side. If I do This, on this side, I have to do the exact same thing to the other side. That's why I'm going to wait until later. All right, so all I've done is recopy what I had on the right side of the equation. What this should equal is 5 over 2, and I'm going to replace this k and this k right here. Do you get what it should come out to? Is if I had replaced the k's with k plus 1s. And that k right there with a k plus 1. So if I can make the left side equal the right side, then I have proven this. All right. When you're proving, just to clarify something, a lot of times people want to mess with stuff on the right side and the left side and like adjust things on the right and adjust things on the left. You can't do that. If you're proving something, I don't know if you remember this from higher algebra, we did a proof. If you're proving something, you can't change the end statement. I cannot mess with this. This is what I'm proving it's supposed to be. I can't manipulate that at all. That's got to stay the same. But I got to be able to rearrange this sucker until it looks like that. And at the very end, I should be able to say, I did a bunch of math steps here, that it comes out exactly the same. 5 over 2, k plus 1, and then k plus 1 plus 1. That's what the left side should read because that's what the right side reads. Get what I'm saying? If you're trying to prove something, you can't change both sides. You can only change one side. That's a good thing to understand in pre-calc, is what's allowed in proofs. So in proofs, you can't touch, it doesn't necessarily have to be the right side, but we always set it up that way. You can't touch the right side. So now the left side. Who can see something smart we could do? Follows one of my rules of how to solve tough math problems. Come on, you can do this. Name some of my favorite sayings. Can factor, you should. It applies. Can you see what can factor out? No, that's not one of my favorite math sayings. That helps with synthetic division, yes. But if you can factor it, you should. Do you get these both have a k plus 1 in them? I am going to factor that to the front. The k plus 1 comes to the front. If you factor something, you're really dividing by it. What do I have left after I divided by that? K plus 1. Come on, you can do this. Effectively, I divided by k plus 1 here, and I divided by k plus 1 here. And so what? What's left? 5k over 2. Because see, this cancels. You guys, you can do this. I'm not doing impossible math here. I just divided by k plus 1. All right. So what's left on the other part? Plus what? Plus 5. Because this would cancel this. Okay. Is that like wizardry? No, I just factored out a k plus 1 from both parts. Does this look exactly like this yet? Then I haven't proven anything. So what else can I do? Yes, ma'am. Factor again? I love it. The k plus 1 can't be factored, but the other part can be. What can factor out of both of those? Got to be careful here. 5 can come out of both of those. Good. 5 comes out. What do I have left? K over 2 plus, not a 5, because plus 1. Does the left side look exactly like right side yet? No. But if you know where you're going, it's easier to get there, right? So, what do you think? I'm trying to get this to look like this. I got the k plus 1 out. It'd be nice if I could get the over 2 out somehow. Multiply everything by what? If I multiply both sides of an equation, I can do that. Okay, wait. So you're saying that's legal. Again, what she said, I can't just multiply everything by 2. If I have an equation, you do that to both sides. But remember, I say no touch over here. I cannot multiply both sides by something. That's not legal. Not in a proof. Okay, so he just said I could take this 1 that was here, and I could replace it with what? 2 over 2 is the same thing as 1, isn't it? Basically, aren't we just getting a common denominator? It was 1 over 1. That's what 1 is. And then to get a common denominator so I can actually add those together. It involves common denominators. That's awesome. So now I'm going to make this a little simpler here. I still have k plus 1. I want that because it's in my final answer over here. And I still have a 5 in it. I want that because I need a 5 in my answer. But I got to get that divided by 2 out somehow. K over 2 plus 2 over 2. Come on. So close. What do you think? I like it, but there's another way to say that. If you can factor it, you should. And so, what are we really doing? Factoring out what? A 1/2. You're factoring out a 1/2 from everything. Here's another way I could say it. How about we just add them together? Because I think this factoring out a half thing is going to blow too many minds. It's not impossible, but do you get, if I just added this together, it'd be k plus 2 over 2? If I just add them together, k plus 2 over 2. Actually, no erasing. That's not allowed in proofs. All right, so k plus 1 times 5 times k plus 2 over 2. Now do you get how I can get that 2 out? K plus 1 times 5 times 1/2 times k plus 2. And that's k plus 1 times 5/2 times k plus 2. And that's getting really, really close to what we wanted to prove, which was k plus 1 and a 5/2. I got that. And I just have to get that k plus 1 somehow. Not that hard. What's k plus 2? Same exact thing as. Can I replace the 2 with a 1 plus 1? Isn't that now exactly the same thing as what I wanted it to be? Oh, there's a parenthesis missing, but I can put parenthesis around that. It's legal. Same thing. Now, it's exactly the same on the left side as on the right side. I guess I could reverse the 5/2. I wouldn't be that tough on you. Once you've broken it up into its factors, that's the main thing we needed. But yeah, I could put the 5/2 in front, and then the k plus 1 here. And then the k plus 1 plus 1. And now it's exactly the same on the left side as it is on the right side. I get the algebra on that was intense. It involved common denominators. It involved, if you can factor it, you should. It involved lots of like moving things around, but it was not, none of that was above your level. You can handle all of that stuff. All right, so summary. What have you learned in the last 29 minutes and 45 seconds? We're going to give you a fact. we are never going to give you a false statement because this is hard enough. Okay. Then you're going to, step one, let's not even have it up there. Tell me, what's your first step in proving something's true? Make sure it works for what? Any one number when we're going to use 1. Okay. So you check it for 1, see if it works. What's the next step? Kind of weird. Set n equal to k. Good. Because we want to use k for all math induction proofs. I don't know if it's because it's induction or what, but anyway, however you want to remember it. And then what's the next step? I got to prove if I changed it to k that it would also work for k plus 1. And so back to our slide here, when we knew that it worked for k plus 1, we added the next term here, and whatever we add to the left side, we have to add to the right side. Then, this is where it got intense. All I did is recopy this and say, now that should come out the same as if we had stuck in a k plus 1 here and here. And so that's this giant statement here. That should come out equal to that. And then if you're doing a proof, you can never touch the right-hand side. You have to leave that alone. You might be tempted at some point to like multiply both sides by 2 or whatever. Can't do that. Don't touch the right side. The left side, just keep on manipulating the left side until it ends up being exactly the same as the right side, and then you've proven it. Yes? Does it matter like what one is on each side, or could be changed? Actually, they could be rearranged if you want to have the left side be the side you never touch. But just one of the 2 sides, you can't ever touch. And you manipulate the other one until it equals the other one. Okay. Let's see if you really understood that. I'd like to go to that problem right there. Problem 1. It's purple. It's got the little dollhouse on the right side. Sculpture, whatever that is. Looks kind of like a dollhouse. All right. Everybody start by doing step 1 on it. Yes, sir? Page 6 on your document, apparently. Okay, so step 1. In the back row, Mr. B, what's step 1 again? Right. So prove for n equals 1. Prove it works for n equals 1. These steps, what they say in the steps, is part of actually proving to me that you know what you're doing. So if you aren't able to tell me what's step 1 in the induction proof, you won't get the credit. You're proving that it works for n equals 1. Well, if n equals 1, there's only one term. And so we don't need all these terms. We just need the last term, which is the same as the first term, right there. So you get what we say, 1 equals 1 times 1 plus 1 over 2. And does that actually come out to be a true statement? Yes. 1 is equal to 1 times 2 all over 2, and the 2's cancel, and 1 equals 1. Yay, I proved it. That's my first step. How many of you got that far? Cool. Then what's step 2? Yes. Yes. Now all you have to do is rewrite the whole original problem, the whole thing, with a K. Jay, would you read that to me, please? Yep. No, the whole equation. There we go. That's not the original equation. I'm wrong. You're right. Sorry. I was doing step 3. Sorry. Keep going. Equals. There you go. Sorry about that. The next step, we're going to have to add an extra term after that K, and that's what I was thinking we were doing. Okay, so step 2 is just replace the thing with a K. That's simple. Okay. 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 All right. So let's move on to step 3. Seems kind of logical after step 2. Mr. Y, tell me what to do. Just generally, what is step 3? Prove it works with k plus 1. That's the next term. Okay, so now I'm going to rewrite this thing like you said. 1 plus 2 plus 3 plus dot, 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 k plus 1, because that'll be the next term. And I'm going to do it in a different color just to make it really clear. This is the new thing on the equation as I'm adding k plus 1 to it. And tell me what to write on the other side of the equation. Awesome. Now I'm going to do that in red just to accentuate. All we really did is took the original and we added k plus 1 to both sides. And that's legal in an equation, right? As long as you do the exact same thing to both sides. Mr. G, tell me what to do next. By the way, if you got this far, that's all you have to be able to do to get a acceptable on the test. To get A slash beyond A even level work, as in maybe extra credit somehow, you'd have to be able to do this algebra part. Tell me what you think we should set up. All right. Okay, hold on. I'm just going to rewrite a statement. Can you tell me the big statement that I should be able to prove this is equal to this? I'm going to just rewrite the original. K plus 1 over 2 plus k plus 1. Do you get where I got that second part right there? All I did is said, I just recopied this. I actually didn't say it, he said it. How did he get this part over here? It's if instead of just adding k plus 1 at the end, we had done what some of you think should have happened, we replaced the k with a k plus 1 here and here. That's the thing we have to prove now, is that this piece right here will simplify on down and become the same as if we had replaced k with k plus 1. All right, so can anybody do some algebra that's going to actually make this happen? The left side has to come out to equal the same thing as the right side. Come on, you can do this. What do you think? So you want me to put a 2 right here? But wait, okay, you can't just multiply anything we want by 2. I can multiply that all by 2 if you want to, if I also divide it by 2. Can't argue with that. Okay. K times k plus 1 plus 2 times k plus 1 all over 2. Oh, that's really close to being the other side, isn't it? Because now we got it over 2. I'm sorry, just explaining what you're doing. Now we got it all over 2, which is one of the key elements. It has to all be over 2. And now if we could just get that other part, and then what do you want to do now? Use my favorite saying. If you can factor it, you should. And I see a k plus 1 here, and I see a k plus 1 there. And I factor them out to the front. K plus 1. And then what's left after I pull out that k plus 1 and that k plus 1? k plus 2 all over 2. And we're really, really close to being the same as the other side. Now we just got to do a little rewriting. Mr. D, even back. Finish it. So close to equaling the right side, but it's not quite. Yep, you can split this k plus 2 here. Used to be a k plus 2 there into a what? And can I throw an extra parenthesis around something? Will that hurt anything? No, it won't hurt anything. And now, I think it looks the same as our goal statement, and it does, and that means we proved it. All right, I've noticed some patterns as I've done a few of these. The algebra part of it pretty much always involves, well, why don't you tell me? What did you notice in both problems we did? It involved 2 skills, factoring and common denominators. I would be shocked if you do any that don't involve factoring at some point or common denominators. Okay. Do you have to be able to do all of the problem? No. What steps do you have to be able to get set up through? All the way set up through step 3. It's just at the end of step 3, you don't have to actually grind out all the algebra to prove that, but if you can, that'll be worth some extra credit for you. Or credit that will help you get closer to an A, I'll say it that way. Yes?
So if we get step 1 through 3 right, but then we try the algebra.
You won't be penalized for trying to do the algebra and getting it wrong. You would not be penalized for that. As long as you got steps 1 through 3 right, boom, you automatically got credit. You know how to do induction. And I don't even want to say you want to know how to do induction. You know how to set up induction is a safe thing to say. If you can get up through step 3. Yes, sir. It's a problem on a test, and you get full credit for the problem on the test if you can get up through step 3 all set up. You get more credit, and I don't know exactly how we're going to do that. We've just briefly discussed it, but you get more credit if you can go all the way to the end of an induction proof. I'm just trying to make it clear to you. I understand that these are insane, and you aren't going to have to be able to do one all the way to the end to be able to get a decent grade on your next test. But if you can, it would help you get a good grade on your next test. Yes? Good question. How do we get from the black to the red? Did you get the previous step to that? Did you get how we multiplied by 2 over 2 in black there? Okay. And so then all that happened there is we factored out the top. So the black one, if I brought it back to what it was, I'll just get rid of this crossing off stuff here. That's what the black one looked like. Do you get that the top has a k plus 1 in common on both the left and the right side of it? That k plus 1 gets factored out to the front, and then what's left after you factor out the k plus 1 is a k plus 2. This here is common to both parts. So we factor it out to the front, and it's right here. This k. You think of it this way. If I multiply this all back out again, I'd have the same thing as if I multiplied the top, this part, out. Both that and that, the ones I just drew the big horizontal arrows towards, if multiplied out, would give you the same thing. Really, what I want you to think of it is the bottom didn't change at all, right? The top got factored. There was something in common. The thing I circled was in common. All right. So let me show you your homework, and I'll get it started with you. We have a little slightly different system for doing homework. And your homework starts right there. It says assignment day 1. And note underneath them, we are going to start giving times. Because we knew that you know how sometimes I give you a problem and I was thinking it was the easy one, it's actually a really hard one? Okay, by having times in there, that means they're pre-checked to know easy one, hard one. 10 minutes, kind of a hard one. Okay, these proofs are obviously challenging, and they're 10-minute questions at least. Our goal, by the way, you'll like this number, is that we give you 20 minutes of homework. That's our goal. Now, does that mean everybody only takes 20 minutes? No, I could spend an hour and a half on that problem if I don't know what's going on. You know what I mean? So, depends on you, but we're aiming for 20 minutes of math homework, and that's a very reasonable number. A lot of teachers aim for like 45 minutes of math homework. This is that's reasonable. That's not crazy talk. All right, so number one, let's get it started. Step one. Step one is to prove it works for n equals 1. So I'm just going to take that, because I don't need all these terms, just the first term, which is actually, in this case, the last term. And I'm going to put in 3 times 1 minus 2 equals 1/2 times 1, 3 times 1 minus 1. And hopefully, when you work that all out, it actually is the same thing on both sides. I understand. So let's do it. 3 times 1 is 3 minus 2 is 1 equals 1/2 times 1 is 1/2 times 3 times 1 is 3 minus 1 is 2. 1/2 times 2, and that is equal to 1. So there. Step 1 was easy. Stick in a 1, prove it for 1. All right. Step 2 is a little weird. What is it again? Yep. You have to label your steps. Can you rewrite with a K? Have a good day. And for those of you advanced students that are going to actually solve this thing, step 3 is where you have to be able to set it up through step 3, but solving the algebra is really tough. I'm going to get it set up through step 3. Step 3 is to make sure it works for n plus 1. So I rewrite the whole formula again. 1 plus 4 plus 7 plus ... plus 3k minus 2 plus the new thing we're adding is one more thing, which is the next one, k plus 1. Sorry, this should be a k. And therefore, I need to add 3 and replace the k with a k plus 1 in the middle of something right now, minus 2. And that's the left side. Then you have to add that same exact term to the right-hand side. Pause for a second. Okay, so, sorry I had an interruption there. I just want to finish up setting up this problem. So I'm going to move this stuff over so I have room to say, what should that be? That should be the same. I'm going to bring this straight down as 1/2 k, 3k plus, no, minus 1. Minus 1. And then if I added this to the left side, I have to add it to the right side. So plus 3k plus 1 minus 2 has to be added on the right side as well. So now I've got this has been added to the left and it's been added to the right. That's the setup for step 3. All right, for solving step 3, to finish it all the way, now I'm going to recopy this down here. I have to say that 1/2 k times 3k minus 1 plus 3k plus 1 minus 2 should equal, and a lot of kids have trouble understanding where this next part comes from, but if I hadn't added this piece and instead had replaced each k with a k plus 1, I'd have 1/2, and then instead of this k here, I'd have k plus 1. And instead of this k here, I'll have 3 times k plus 1. And then minus 1. If I could prove that the blue side on the left is equal to the black side on the right with algebra, which you can, I'll give you a hint. You want to multiply it all out, not all the way out, but you want to multiply it out so that it has a common denominator. This one's got a fraction denominator of 2, and you got to make this part have a denominator of 2 also by using common denominators. Once you get it to have a common denominator, you just have to factor it, and it's pretty much done. So that's your first problem of your homework, and I'll let you finish it for your homework. And that's all I have for the video for today.